All right, guys. This is question here, right? So we are solving this question. You are given an integer array nums, right? And we have to return maximum possible sum of sub-array of nums, and that is a palindrome also. Okay. Let's see what it is saying. So return the maximum possible sum of sub-array nums, that is a palindrome also. Okay. So let's take this example. So this is array. We have to find the maximum sum, okay, of sub array. Max sum sub array, uh, which is palindrome also, okay. So we have two problems in one. Like we have to find the maximum sum of sub array, okay, and then we have to check if that is palindrome or not. Alright. So here it is. This is the solution in this case. So let's say this is array, right? We check, okay. If it is palindrome or not, no. If it is palindrome or not, no. If it is palindrome or not, no. If it is palindrome or not, yes, it is palindrome. Right. So, so we check the sum of this, right? Where we again go for palindrome. Then we go for here. Like this is just brute force, right? We are checking all the sub-arrays. Alright guys, so we were doing this question, right? So this continuous average there and it's a palindrome, okay. So this is just brute force which will be order of n square, right? We don't want order of n square solution. We want optimal solution, right? So to this is the okay, right? So let's go by centers, right? Center, what is the center? 1 2 3 2 1 5 6, okay. 1 2 3 2 1 5 6. This is the center, right? Is this palindrome? Yes. Sum is 1. If this is the center, right? So we just take left. If it is same, then okay. Let's say if this is the center, 3 is the center, then this or this should be the same, right? Whatever it is, then it is palindrome. Then this is the center, like this. Then we check full here and full here, right? Make this the center. So for every center, let's say how many palindrome we can go for from it, right? Here, here. So we should not take any less, right? Because any less will have the less sum here, right? So for this we have a we have a called a miniature's algorithm. Okay, if you know, you know there is a miniature algorithm. So for an array, alright, for an array, let's say instead of a string, right, equality is still equality here, because nums of I is equal to nums of j, right, like this. So what this miniature algorithm do is it computes like d1 of I, right? This is like this will compute radius of longest odd palindrome. Okay. D2I is like it computes radius of longest even palindrome. Okay. Between it will be centered between I minus 1 and I. Okay. So it all works in order of n time. Okay. What is prefix sum for us? Prefix sum is like prefix sum of I plus 1 is equal to prefix of I plus nums of I. Okay. Sum of L comma R is equal to prefix of R plus 1, right, minus prefix of L. This is for us the order of 1, right? Because this is here. Okay, so what will be the algorithm to solve this problem, right? Algorithm will be like this. For every center, for odd palindrome is like this, right? Radius is equal to d1 I. I is equal to I minus radius plus 1. R is equal to I plus radius minus 1, right? Longest palindrome at the center. At this center. Okay, like that. So first we compute the prefix sum, right? Prefix sum for each index, right? Like 0 over first index, 2 index. Then we get L or R for with the radius. This L is whatever the center I. What is the radius minus radius plus 1, and R is I plus radius minus 1, right? So what we do then, sum of L comma R is prefix sum of R minus prefix sum of L, right? We find that, right? Then we find the maximum sum. Okay. And in case of even palindrome, right? It's like radius is equal to d2 of I L is equal to I minus radius, R is equal to I plus radius minus 1, like that. For example, like we have 1 2 2 1, right, and I is here, I comma I plus 1, right, this, or we can say I is here and I is I minus 1. These are centers. I is here. So what is the radius for this? This is 1, right? I minus radius is what? This is 0 1 2. So I is here like this. Okay. I minus radius. Okay, this is 2. Okay, this is the radius here. Whatever the I L is. So let's try to solve this. Okay, let's try to code this. So let's solve this, guys. We have this integer array, right? Nums. So integer n is for size, right? Get the size of the array, and after that we will have a prefix sum, right? We need that vector of long in this case, because it can go like nums of I values like 10 to the power 9. So if we are getting its sum, so it can exceed the integer limit, right? 0 like this, and then populate this prefix sum array. Okay, like this, prefix of I plus 1 is equal to prefix of I plus nums of I. Okay, like this. And after that, we can go to range sum, right, is equal to integer L comma integer R. Okay, then it will return prefix of R plus 1, right, minus prefix of L. So for it is for getting the range sum. Okay, so range sum we can pass L and R in the range sum function, and it will return this. This is one other type we can define a function, right? Then okay, so we have to do this also here. Then after it we have long answer is equal to 0, right? So for odd length we are checking, let's say for odd length array, right? Vector of integer d1. Okay, d1 is like for getting a center and int L is equal to 0 or int R is equal to 0. Okay, or we can reply R with -1. I will tell you it why. Okay, then for int of I equal to 0, I less than n and I plus plus here. What we do? Integer k is equal to I greater than R. If it is, then k is 1, else it's a minimum of d1 L plus R minus I, comma R minus I plus 1. Okay, if I is greater than R, then k will be 1. Okay, radius will be 1, right? Else radius will be what? Minimum of this after it, while I0 is less than equal to I minus k, and I plus k is less than n, and nums of I minus k equal to nums of I plus k. Okay, till then we k plus plus, and after that k plus plus d1 of I is equal to k. Okay, if I plus k minus 1 is greater than r here, then l is equal to I minus k plus 1 and r is equal to I plus k minus 1 right here. Okay. And then into left I minus d1i plus 1 and the right is equal to I plus d1 of I minus 1. Then answer is equal to max of answer comma arrange sum left comma right. Okay. Let's understand how it's working. Right. Let's just understand this here. Okay. First, what it did, it has a vector of d1 of size 1, right? Here. Like this, right? So this is of size n, something like that, right? Let's take the example from here only. 1 2 3 2 1 5 6, right? 1 2 3 2 1 5 6, like this. Okay. Okay, like this. Alright, this is the array we have. Similar, we will have the D1 array for this. Okay. Similarly, we will have the D1 array also for this. Okay, like this, and then this is D1 array. Okay, and L is equal to 0 for right now, and R is equal to -1. Okay, now there is a for loop, right? You can see here there is a for loop here, this, right? So this for loop, what it will do, for I is equal to 0, I is less than n, I plus plus, int k, right, int k is equal to I greater than r than 1, right? Is it I is greater than r? I is minus 1, I is 0, and R is 1. Then K is equal to 1 here. Okay. So K is equal to 1 in this case. Then while there is a while loop also like this, while 0 is less than or equal to I minus K, and I plus K is less than or equal to N. So what is I? 0. I is K is 1. 0 minus 1 is minus 1. Is it true? No. So we are not extending 0, right? So after that, then we what we will do, d of I is equal to K. So center is K, this is 1, right? We are I is here, right? Then what we will do, there is a condition called, okay, if I plus K minus 1 is greater than R, I 0 plus K is what? 1 minus 1, which will be 0. Is it greater than R? Yes, it is. Then L will be I minus K plus 1. So 0 minus 1 plus 1, which is 0. Okay. R is equal to I plus K minus 1. I 0 plus 1 minus 1. This is 0. L is here also, R is also here. Okay. Then what is the left? Left will be I minus d I plus 1, which is 1 here, 0 minus plus 1, which is 0. Okay. Right also 0. So left, right, L and R both all are 1. So this is the palindromic window we have right now. Okay. So what we will do? We will find the sum. Right. There is a sum also. Right. There is a function answer is equal to max of answer comma range sum of left comma right, which will give us a 1. Answer is 0. So answer is 1 right now, right? Like this. Then again this for loop, I will come here, right? I will come here. In this case, let me tell you. In this case again, what is K? K will be, K is this I is greater than R, right? So L is 0, R is 0 right now, right? L is equal to 0, R is equal to be 0, right? Is I is greater than R? Yes. Then K is 1. Else it is minimum of D1 R L plus R minus I, comma R minus I plus 1. Okay, we will see that. So I is greater than R, yes. So K is 1 right now. And there is a loop also, while I is greater than or equal to I minus K, and I plus K is less than N. Okay, then nums of I minus K is equal to nums of I plus K till then K plus plus. Okay. So I am checking. Okay, if what is I? I is 1. I minus K is what? K is 1 right now. I is 1 minus 1 is 0. So is I is less than I minus K? No. So we will not do K plus plus. Okay. And d of I is equal to K. K is what? 1 only right now also. Right. Then what is L? Right. There is a condition also, like after this. like if I plus k minus 1 is greater than r, okay, then L is equal to I minus k plus 1 and r is equal to I plus k minus 1, like this. So we are updating L and R values. I plus k is what? 1 plus 1 is 2 minus 1, which is 1 is greater than r. R is 0, it is yes, okay. Then we will update L and R right now. I minus k plus 1. So I minus k plus 1. So L is 1, R is also 1, I think. What is R? I plus k minus 1. I is 1, k is 2, minus 1 is minus 1, okay. Alright, both are 1. Then we have what is left and right? Left is equal to I minus d of I plus 1. Right is equal to I plus d of I minus 1. Okay. So what is d of I? Which is 1. So I is also 1. So 1 and 1. Both are 1 and 1. And for this literal meaning, the sum will be this is 2, right? So answer will be 2 right now. Answer is equal to what? Max of answer comma range sum left comma right, like this. So what is left and right? Which is 1 1. So answer is 1 right now. So now it will become 2. Okay. Now let's move I from now here. Right. Let's I is here, right? Let's see. I is here. So I is equal to 2 right now. Okay. Is I greater than R? Yes. Then k will be 1, right? So k is 1 here. Now while I is less than I minus k, less than equal to I minus k, I is what? I is 2. What is I minus k? I is k is 1, 2 minus k is 1. So is I less than? No. So we will not do k plus plus. And let's update L and R. So L is I minus k plus 1, I plus k minus 1 here. Okay. What is L? I is 1, 2 and k is 1. 2 minus 1 is 1, 2. L is equal to 2. R will be also 2. Okay. So this will become 2, 2. And d of I left is equal to d of I. D of I is what? D of I is here will be after this k plus plus there is d of I is equal to k. This is 1. Okay. D of I is 1 and all of things will be this and sum now will become 3. Okay. Then I becomes C, comes here 2 for 2. Okay. I comes for 2. I is equal to 3 right now. Is I greater than R? Yeah. Then one window right now. no, it is not like this. It is not I. It is 0. Okay, it's 0. All right. So that's why. So there is no harm right now. So I is greater than R, which is correct. So k is equal to 1 right now. Okay. I is 3. So 3 minus 0 is less than 3 minus k. Yes, right? Because k is equal to 1 right now. So k is 1, and after this I plus k is less than n. Yes, and nums of I minus k and nums of I plus k is equal to yes, then k plus plus, then k becomes 2. Is it like okay, k becomes 2 because it's here 0 1 2 3 here, k becomes 2. For this should be like this, right? So this was the center, we like missed it. Yeah, this is how it's working, guys. Okay, if you understand it. So I minus k, like indexes we are checking, right? Then it is in the range, then we check the index. Okay, why we are providing I generator? We start with the minimum window first, right? Just window k is 1, window size is k. Okay, so minimum of d I l minus r comma I minus r minus I plus 1. Okay, left plus r okay, so that's how it solves, right? Then we code for even, right? After this we code for it even length, right? For this we also have a vector integer of d2 of I at 0 r is equal to minus 1 because I is 0, right? So we have to consider that. For int I is equal to 0 less than n I plus plus. Okay, integer of k is this, I is greater than r. Okay, if I is greater than r, then we provided 0 else minimum of d2 of l plus r minus I plus 1. Okay, from r minus I plus 1, like this. And while 0 is less than equal to I minus k minus 1 and I plus k is less than n, and nums of I minus k, okay, minus 1 equal to nums of I plus k. Okay, till then we do k plus plus, then d2 of I equal to k, right? If I plus k minus 1 greater than r, okay, then l equal to I minus k and r equal to I plus k minus 1. Alright, then we find left and right also. It's like if k is greater than 0, window size is greater than this, then in the left is equal to I minus k and in the right equal to I plus k or minus 1, right? And answer is equal to max of answer, comma then sum Okay, left comma right. Okay, like this. Then at the end we will return the answer. Okay, let's check if it is working or not, and then we, oh, it's all working, guys. Try to submit it. Okay, it's one of the best solutions out there, guys. So yeah, it's nice. So we have to like think with the center thing, right? For even length and for odd length we have to treat center as difference, right? And yeah, and why only longest palindrome we are considering? Because suppose the center is palindrome, so okay, that's how it was, guys. And division game we have done this. Okay, did I able to done this yesterday or not? Okay, it's very not very efficient solution here. It's accepting but very not efficient one, right? So what is the question? Let's understand this here. Then first, then we will go further from here, right? What was the question? Question was, you are given two string s1 and s2 of the same length, and you can choose an index I such that s of I is 0 and change it to 1, and you can choose index I such that like this. Okay. So what I did in this was, guys, Alright, so that's what I am doing. So what I did is I took this n of s1 length, right, and is a an infinite I decided. Okay, then based on the dp of 0 is the minimum cost to match prefix if current physical state is 0. dp1 is the minimum cost to match prefix if current physical state is 1. Okay, so that was the case. So vector of dp of two sides with infinite. Okay, so current state can be 0, can be 1, right? So that's why we are taking two things only. So initialize the base state with the first character of s1 as okay. So dp of s1 0. If it is 0, then it will be 0. We are not changing. If it is 1, let's say dp0 is 1, right? 1 minus 0 is 1 only. So we are not changing that also. dp of 1 is also 0. Okay. So if it is 1, so dp of s1 is 1, then first character is 1, then its dp of 1 will be 0. If first character is 0, then dp of 0 is will be 0. Okay, then we are going from 0 to less than n plus I, and we are in next dp. Okay, we are getting this next dp here. Let's say same thing, and t is what s2 character, whatever it is. If it is 0, then it's 0 index. If it is 1, then it's 1 index. Okay, so general state transitions for I less than n minus 1 like this. For integer of c is equal to 0, c is less than 2, and plus c. So if a dp of c is equal to infinite, then continue. Okay, which means dp is this, right? If it is infinite, like first character is not there, not equal to this. Okay, then continue in this. If it is not the case, if c is not equal to 1, if t is 0, what is c? C is 0, c could be 0, c could be 1, right? Index, it is for index. Okay, if c is 1 and t is 0, what is t? T is also index of s2, s1, right? No, s2. Alright, wait a minute. Okay, let's try to do this solution first, guys. Then we can check it if it works or not. Right. So this is a question, guys, for us. Okay, and we will try to solve this. Okay. So this is a hard problem. 3981 number of Leet code. So you are given three strings like word 1, word 2 and target, right? Now you are asked to count the number of ways to form target by choosing character from word 1 and word 2 under the following conditions. Okay. For each character of target, choose one matching character from either word 1 or word 2. Okay. A chosen industrial from word 1 must be strictly increasing. Okay. And chosen industrial word 2 must be increasing. Okay. So at least one character must be chosen from both word 1 and word 2. So at least one character must be chosen from both. Okay. So two ways are considered different if at least one position in target a chosen character comes from a different string or a different index. Okay. So return the number of ways. Since the answer may be very large, so return with modulo this. Alright. So let's just take this example here, right? Yeah. Alright. Take this example and try to solve this here. We have word 1 ABC and word 2 BAC and target as ABC. Okay. And we need to build what? ABC. From picking characters from here and here. Those characters should be picked in an increasing order of the index, right? And for every character we have two choices. We can pick it from word 1 or we can pick it from word 2, right? And those should follow this rule, like chosen indices must be increasing. Like if I choose from here 0 index, then next I have to choose from 1 index, right? So first character is what? It is A here. And at word this, at index 0, this is also A, right? But in word 2, it is at index 1, right? So immediately we need, like, we have two branches here, like we need what, we need a, we can choose like a word 1 0 and word 2 1, like this, right? This is one branch. Now suppose we picked this here, right? Now again we need B. Okay. From this branch we have picked, this is we again we have two branches, we can pick word 1 1, right? And we can pick because we didn't pick this, right? So we can pick word 2 of 0, right? Like this. Okay. Then continue for C like this. So what information do we need? So suppose we already picked word 1 3 C. Okay. Right. So the next character, okay, for that, in that case, if we have chosen word 1 3, the next character cannot use word 1, right? Word 1 1 or word 2, because indices must be increasing, right? So we must remember that last use index in word 1, so we have to remember that, right? So similarly we should remember last use index in word 2 also. Okay. Another condition is, the problem says at least one character must be come from both strings. Okay, so we must also remember. So have we used word 1 and have we used word 2 or not? Because we have to use both at least once, right? So in that case, what things we have to remember in a function solve? First is target index, right? Then we have to remember last index in word 1, last index in word 2, right? And we have to, is used one word is used or not, and used word 2 or not, like this. We have to remember all of those things. Okay. And like, it's meaning how many ways I form the remaining target. So what is the best case in this? Best case is like if target index is equal to target length. This is the base case, right? When it is like this. Like, which means we have formed the whole target. Now check, did we use both strings or not? Like, if we used word 1 and u2 are true, then return 1 in this case, okay? Otherwise return 0. Alright? Alright, so this will be a base case. If word 1 and word 2 are used, then return 1, else return 0, right? And then we have to search every position after last index word 1, right? If character matches, so pick it, and then recursive call, like if character match, if a match, then what we call, like solve if I plus 1 is last index, then new index from a last index of word 2 and true, and used word 2 like this. Chose to do the same in word 2 also, right? If it is matching or not, and recursive call for us. The complete recursive tree like this, and so let's try to solve this question with brute force. Okay, all right. So this is the brute force for us. We have a function called int solve, right, which will take, okay, int target index, integer last of 1 and integer of last of 2, right, then bool used 1, bool used 2 or not, right, then it will also have a string as word 1, right, then it will have a string of word 2 word 2, right, like this 2, and then we have a string which is target, right. Okay, so what is the base case in this? Base case is like this. If t is equal to target output size, okay, if it is like this, then we have to show, okay, if we used both or not, right, if we used 1 and used 2, then return in that case return 1 in that case, else return 0, right. After this we will have the answer equal to 0, and we will check the indexes for all, for int I is equal to last 1 plus 1, right, whatever we used, I less than word 1 dot size, because both are similar length, right, this doesn't matter what is I or not, I plus plus. Okay, then if this index matches, right, if word 1 of I is equal to target of I, right, if it is the same target t, okay, target index, okay, like if we are able to find that, okay, target index here, if it is like this, then answer plus is equal to solve, because we are using this character, right, solve. In this case what we go to do, t plus 1, because we found that we index, then I last used i's, then last 2 is the same because we are not using that, and we are using this true, and used 2 after this word 1, okay, comma word 2 comma target, like this, okay, if it is matching. And similarly we do this for word 2 also, for int j is equal to last 2 plus 1, comma is less than word 2 dot size, right, j plus plus. In that case, if word 2 of j is equal to target t, right, target t, then if it is matching, then answer plus is equal to solve, target will be increasing, and it will be like last 1, but we are not, and then they will use the then it will use 1, then it will be true. Okay, then word 1 comma word 2 comma target, right, like this. And after all of this we can return answer whatever it is. And just a minute, we have to reset this first. Okay, this was the question. Okay, like this. So what I will return from here, return solve, right, of 0 target -1 comma -1, I plus 1 we are checking, false comma word 1 comma word 2 comma target. Okay, this we are returning. So we are just returning the number of ways, right? Can we do this mode also here? Okay, so answer plus this. So in this what I will do, I will use mode. Okay, here whatever it is, like my mode, and then after all of this use mode one more time. Okay, like this. Similarly here, modulo mode, and it's like answer plus modulo mode. I have defined mode here is like this, right? Answer will be mode like this. Let's check if it is working fine or not. Right, it's working here. Let's check if it gives us TLE or not. Right, it should give us TLE. Yeah. So we can use an array for memorization, because so how many indexing, what are the changing variables? Changing variables in this function is t, last one, last two also. Okay, then used and used to. Okay, so changing variables are these. Okay, so I think used or used is not very, but these three variables, t, last one, last two, must be there in because initially we are solving 0, -1, -1, false, false, right here. You can see here, right? suppose later both branches reach its true 1 1 1 like this. So now this stage solved twice, so the answer from this stage is so we have to take the 4D DP because here like this enter the DP of 101. Why it is 101? Because you can see the description here. This is the length of everything is less than 100, right? So because we are accessing -1, so that's why. Okay, target, then word 1 index, then word 2 index. Okay, then this is for mask. Mask is what? Like if we used both or not, if we used 1, if we used 2, if we used both, like this is for mask. I will make sure like this. Okay, it's like 4 states like this. Okay, so mask is like 0 1 2 and 3. Didn't use any, used word 1, in this case used word 2, and is this used both. Okay guys, like this. So this is the state, right? We have to respect every state in that case, right? And we are defining a memory set here. Okay, mem set dp comma -1 we are initializing, and size of dp. Okay, we have initialized dp there, so we are finding memory for that. Okay, and we are initializing with -1. All right. So what we will do, in the solve function here, if it is equal to like this, okay, so if t is equal to target dot size, right, in that case we have to return mask is equal to 3. If it is there, if mask is 3 then it will return 1, right, else it will return 0. So this is the parallel condition for this. Okay, now we have answer. Answer is like this. How we define this? Answer is like this. dp of target, right, comma last 1 plus 1, comma last 2 plus 2 plus 1, right? And mask. This is the answer. If it is -1, then it will do -1. If it is not -1, then it will return like this. Okay. Answer this. Okay. So if answer is not equal to -1, right? Equal to -1 here, then return answer here, right? Else answer is equal to 0 again, and now it is same here because this will be the old same. Everything will be same, right? And this is also same. Just what we have to do at the end. Just we need to change few things in solve is t plus 1 is I, then last 2, right? True. Instead of true, we have to change this denomination, because this is for whatever is mask, we OR with 1. Okay, because we are using word 1 word rest, then word 2 target mode. Okay, then in this case what we have to do, we are using 2. Okay, so in that case whatever mask is with OR with 2, because we are using 2. If it is 1 and this is 2, this automatically makes the mask 3. Okay, then word 1 word 2 like this. Here we just use one mask here, right? Okay, let's check if it is working fine or not, right? Let's check. Okay, here also in the here this is 0 here. Okay, oh, what happened? All of answers are let's check what is the problem. Okay, this is fine, and answer is not going to be an answer equal to 0 in this case. No, we have to like dp of t, right, comma last one plus one, comma last two plus one, right, comma mask is equal to like this. We have to do this like, right. Try this now. Second wrong answer, right. So let's check again. It's good. R1 plus 1, word 1 plus I plus plus. Word I is given target t, then answer is equal to. Let's solve t plus 1, comma I, comma last 2, mask word 1, word 2, target. Find everything. Plus 2 plus 1, so sorry, j plus plus 2, target t, then answer plus solve plus solve t plus 1, last 1, j, mask 2, word 1, word 2, target, modern, and then return this, whatever it is. Let's try to keep this one here, what it says. Wrong answer here, okay. I don't know what is the problem, guys. I think from my side it's all good, right? Mask word 1, word 2, target, everything works. Do I need to ask this to our professional coach? Oh, okay, this is the problem. Okay, it's a int mask. Okay, it's now accepted, guys, here, and it should not give really, I think, now, because yeah, we have one more optimized form of this. I will explain it later. So thank you so much, guys.